Okay, so welcome everyone. Long time. So let's start with the first question. Okay, so the first question is array cloning technique. You are given an array E of an integers. Initially, there is only one copy of the array. Okay, you can do the operation of two types. Choose any array and clone it. After that, there is one more copy of the chosen array. Swap two elements from any two copies on any position. Okay, and we have to find the minimal number of operations needed to obtain a copy where all elements are equal. Okay, so the test cases are 10 to the power 4. Okay, the 10 to the power 4 test cases will be given, and the size of the array is from 1 to 10 to the power 5, and the size of the integers and the array is from minus 10 to the power 9 to 10 to the power 9. And it is clearly given that the sum of n overall test cases does not exceed 10 to the power 5. Thus, we can traverse through all this array, but there is no need of traversing, I guess. Okay, so let's just start with, let me tell you how I approached it. Okay, so consider that you have an array of size n. Let's define n as 5. Okay, so you have A, you have B, you have C, you have D, you have E. Okay, so the repetitive elements, uh, there are no repetitive elements, so we'll take any one of the element as the repetitive elements. Okay, so now we'll clone it. If we clone this array, the same array, we'll get A, B, C, D, and E. So now we can swap these two because I have taken A as a repetitive element. So A and then B. So now uh, of this array, we can clone it once again. So it will become uh, A, A, C, D, and E. Okay. So if we are cloning it, you can see that now we can, swap these two elements and swap these two elements. Okay. So now what we will get of these two, it will be somewhat like A, 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 and E. Now again we can clone it, and then we'll get size 4A, and then we'll swap one of the A with E. So the basic intuition behind this is, let's just say repetitive elements are X. Okay, so if the repetitive elements are X, so basically you have predefined repetitive element. So just take the largest one, the largest repeating element. Let it be x. Okay, the count be x. Okay, so the leftover positions will be n minus x. So now you have to swap for these elements. Okay, so you will swap for these elements, and per cloning, the size of the identical elements increases 2x times. If you can see here, when there was one, after swapping, it became two. Okay, let me just use a different color, I guess. Uh, I don't know. You can see here, it increased. Let me just take this. And again, when we swapped this, then it increased four times. Then again, it increased 4 plus 4, 8 times. If you are getting what I am trying to say, that on every, let me just show you my, you know, the code on every, on every cloning, the number of repeating elements after swapping, it increases 2x times. Okay, so here's my code, and if it is visible, just a sec. Okay, so here is then. What I did was I took a map, as map can store the frequencies of every element. So I just took a map, and what I did was, the first of all map will sort, why I'm taking here, long max of is equal to 0, because the key here will be map sorts the, the table according to the keys. Okay, so the keys are the elements, not the count. So I cannot get the count from here. So that is why I took, a max, a variable as max of count, max and underscore ski equals to 0. And this I am taking out the max of, you know, per iteration. What I did, and after that I am initializing an operation OPR variable to n minus max underscore c, because at the end the swap operations will be that only. Like if you have an array, imagine you have an array of 6 elements, two are repeating, four will be left, then you have to the number of times you clone, you know it will increase 2x times, and you have to swap only for 4 elements. So the swapping operation will be from n minus, we will decrement n, max count times, if you're getting it. Let me just tell you. So if you have, let's just say, an array of 6 elements, okay, and if you have a 2 and a 2, okay, and then you have a 4, then you have a 6, 8, 10. So what you have to do, you have to swap for these four only, okay, because these two are set already. So the swap operation will already be 4, as you have to swap 4 times only. Okay. So the same I have done, and I have taken a clone variable as the number of max elements. Okay. So because max elements, every time it is increasing 2x times. So I'm just making it show that the clone remains less than the number of elements in the array, and as soon as it increases, I terminate this loop, and I just increment the operations by 1, and then print it. It was a good question. So moving on to the next one. Okay, so Greg and graph. Greg has a weighted directed graph. Okay, so it's a directed graph. It is weighted. Okay, so consisting of n vertices. In this graph, any pair of distinct vertices has an edge between them in both directions. Okay, any distinct vertices has an edge between them in both the directions. Okay, okay, okay. So it is kind of an no. Well, you can say that, but let's, because in both the directions, so you can. The game consists of n steps. On the ith step, Greg removes vertex number xi from the graph. As Greg removes the vertex, he also removes all the edges that go in and out of the vertex. Okay. So before executing each step, Greg wants to know the sum of lengths of the shortest paths between all pairs of the remaining vertices. As you know, here it has been specified that all pairs of the remaining vertices. So for the shortest vertices, we have I suppose two, like Dijkstra and Floyd Warshall. So Dijkstra is for one source, many destination, and Floyd Warshall is pairwise. So I guess we'll be using a Floyd Warshall. The shortest path can go through any remaining vertex. Okay, in other words, if we assume a distance IVU, there is the shortest part that between vertices V and U in the graph that is formed by deleting vertex xi. Then Greg wants to know the sum of. Okay, 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 okay. Okay, so what he's doing is we are given we are given a graph, a weighted graph. Okay, we are given a weighted graph, and we have to do what we have to do is we are given the number of the elements that the nodes that has to be deleted. So here it is given. Let me just read the input line. The first n contains the n vertices. Okay, next n lines n integers. The graph adjacency matrix. Okay, graph adjacency matrix. Okay, 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 okay. Yeah, it's easy then. Graph adjacency matrix. It is given like the graph adjacency matrix I and J. Let me just show you once. Okay, so if we are given with the graph adjacency matrix, then E of I comma J is equal to certain variable, let it be Z. So Z here represents the weight of the edge between I and J. This is what is meant by graph adjacency matrix. Okay, so we are given, okay, the graph adjacency matrix. We will just take it. Okay, so what we have to do is we are given certain nodes. Okay, let's just say 2, 4, 6, and 8. Okay, so first we will delete 2 and find the distance, minimum distance between all the pairs. Then again we will delete 4. Then find the distances, no, shortest distances pairwise, all the between all the remaining vertices. Then again 6, then again 8. Okay, so if we are moving in this direction, we will be deleting each node once. So what I got here of an intuition, if we are deleting this way, we can be adding vertices this way, each and each. Like in Floyd-Warshall, you know, what is the basic intuition behind Floyd-Warshall is, we allow the shortest path from any node. Like let's just say if we have a node 1 and 2. Okay, so the outer kth loop represents the number of nodes through which we calculate the shortest distance. So first we can calculate it directly from 1 to 2, then either through one node or either through two nodes. You understand this? So if we are adding 8th, then we calculate the shortest distance through 8, then 6 and 8, then 4 6 8, then 2 4 6 8. Okay, and then we just sum it. Let me just show you my code. I suppose it will be easy. Then just a second. Okay, so what I did was I took the adjacency matrix and a distance array, 2D array, and what I did, I declared a vector of the nodes which are given in deleting order. I just reversed it. Okay, so it will be the nodes will represent in addition order. If you are getting what I'm trying to say, if we are saying 2, 4, 6, and 8, we are deleting it this way. So if I reverse it, we'll be adding it this way. So I reversed it. I applied Floyd-Warshall, the distance, the generalized theorem, the most basic theorem, and I found the minimum distance. Okay, and substituted it, and then for each k, I just summed it up. After summing all those distances up in an answer vector, what I did was I just reversed the vector because we are taking this direction and the question is asked from this direction. So just reverse it and display the answer. It's as you know. Okay, so now if it is clear, let's move on to the next question. Okay, so Vasya and coins. Vasya decided to go on a grocery store. Okay, he found in his wallet A coins of 1 bureau and B coins of 2 bureaus. He does not know, he does not yet know the total cost of all the goods, so help him find out is the minimum positive integer of money. He cannot pay without change or pay at all using his coins. Okay, so the constraints are 10 to power 4 and okay. So what is a basic, what the question wants to say is that you have a certain coin, a 1 rupee coin, A quantity of 1 rupee coin and B quantity of 2 rupee coin. So we have to find the minimum, the minimum value that uh, we can give without receiving a change, or the minimum value we cannot give at all using these all coins. Okay. So let me just rephrase it. Let's just say you have one rupee coin and a 1 2 rupee coin. Okay. So you can give the shopkeeper 1 rupee. You can give the shopkeeper 2 rupee and receive no change. You can give both adding both. You can give a 3 rupee coin and receive no change. But you cannot give a 4 rupee coin. Is that correct? Okay. So what if you have zero 1 rupee coin and you have just two rupee coin? Then you cannot give two. Neither you can give three and four. You should not think of four. You can give two. You cannot give one, because if you give one, the shopkeeper will return you 1 rupee. So that will contradict the question. So the minimum value will be one. So it's just we have to take care of two conditions. When the value of A is zero, when it is zero, then the coins which you will be having will be of multiples of 2, 2x. So you cannot, what you cannot provide the shopkeeper is a 1 rupee coin. So the minimum answer will be 1. Otherwise, if you have A 1 rupee and B 2 rupee coins, then the minimum value which you will not be able to give is the summation of both plus 1. Like if you have one rupee coin and two rupee coin, then you cannot give 4 rupee coin, but you can give 3 rupee coin. So summation of both plus 1. Let me just show you my code. Uh, where is it? Here. Okay, so I just did what I did was 1 rupee one. If one is zero, I printed one. Otherwise, one into two plus one. Moving on to the next question. Okay, so Vlad and candies. Not so long, Vlad has had a birthday for which he was presented with a package of n candies. There were n types of candies, and there are n types of candies, and there are AI types of type I. Okay, so Vlad decided to eat each one candy every time, choosing any one of the candies of a type that is currently the most frequent one. Okay, to get the maximum pleasure from eating, Vlad does not want to eat two candies of the same type. Okay, so he'll be eating, the candies which are most frequent. That is the maximum one. So let's just consider the test cases as 10 to the power 4. Okay, and the size of the array will be 2 into 10 to the power 5, and the elements will be 10 to the power 9. Okay, long, I suppose. So let's just take an example. Let's just take 16243. Uh, 16. Uh, First he'll eat this one, then it will be 1, 5. It will be decremented by 1, 2, 4, 3. Again, he has to eat the maximum one. So he'll thus repeat his, ritual of eating the frequent candy, that is the maximum one. So in this case, the answer will be no. Yeah, correct. Okay. So what I'm trying to say is he cannot alter between candies if he has the maximum one and maximum 1 minus 1. Like let's just say if you have a array of n is equal to 4 and the elements be 2, 3, 4 and 5. So if you eat first of all this one, then it will be decremented by 4. But then you can alter between these two, if you're getting what I'm trying to say. That is, there has to be an element that is maximum and an element that is maximum minus 1. If m is the maximum element, there has to be someone maximum minus 1. So after eating m, you will have m minus 1 candies of the type m. Then you can alter between maximum and the second maximum. Let me just show you my code. What I did was I took an array, I took a vector or an array. Oh, okay, no problem. So if n equals 1, and if n equals to 1, that means if he has only one candy, and if he has only one candy and he have x quantity of that candy, he will be forced to eat that same candy for x times. So the answer will be no. Otherwise, if he has only one candy, then he'll eat it once, no, following his ritual. So the answer will be yes. Otherwise, what I did was I just sorted the array. I could have done like taken the last one and the second last one and see if the last and the second last, you know, have a difference value less than equal to 1. So it will be a yes, otherwise a no. But what I did instead was traverse through the whole array and took the difference. Same thing. Okay, so let's move on to the next question. Okay, so get an even string. A string is a string. A1 A2 is called even if it contains you know concatenation of strings of length 2 of the same characters in each word. A string A is even if two conditions are satisfied at the same time. Length is even, and for all odd ai is equal to ai plus 1. Okay. Okay, so for example, the following strings are even. TT A B B. Okay, 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 okay. So it is given that the sum of modulus of length, that is the length of the array, will not exceed 2 into 10 to the power 5. So we can traverse through the whole array. Okay, so basically what he wants to say is a string is said to be even. Let me just, okay. So a string is said to be even. Let's have a string. What is a string? A string is an array of characters. Let its size be 7. Okay, so if I'm starting with the one based index, let's just start with the one based index. So 1, 2, 3, 4, 5, 6, and 7. Okay, first of all, this is not an even because it has to be of length 8 even. So let me just take a length even. Let's just take 8. So again, the 8. Okay, so now this is of even length, but whether it is even or not, let's just see. So the odd places should have repeating elements. If one has an element x, two also must have an element x, then three, then four, same, five, then six, same, seven, then eight, same. Okay. So you are given a string. What you have to do is you have to find out the minimum number of character that must be removed. You know, what you can think of it is the maximum even string that you can make from the given set of characters. Okay. So let me just take an example like AABB, AABB, DAB, A, 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 B, B, D, A, B, D, and I think triple C, not triple C, 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 C. Okay, so from if we are starting from one based index, so it will have three, four, then five, then six, then seven, eight, nine, 10, and 11. Okay, so the odd indexes should have AI odd index and plus oneth character same. So here it satisfies. Here it also satisfies. So D, and instead we don't have the sixth element as same as the fifth element. So what we can do is we either delete this D as a whole, or we search for another D, from that index, and then we delete the elements in between them. You can do this in either ways, using a greedy approach or a DP approach. A DP approach is like the efficient one. What I did was a greedy one. So I would show the greedy one, I guess. Okay, so let me just show you my code with this. So it will be helpful in understanding this. Okay, so what I did was I took the string and check for the latest occurrence of each character. Okay, so let me just get back from. Okay, so what I did was I checked for each character A, B, C, and D. What I did was I made an even string with each one, and then I noted down the last occurrence of it each and every time and found out, the answer. Like if I have the first occurrence, okay, so from here it will be zero, answer will be zero. The first occurrence, if I take another two, then the shortest, the even string I will get is of length 2. For this, it will be 0. For B, I'll check if B appeared, previously. If not, then it will be the index minus 1. The same answer will be 2. Yeah, B appeared in this. It had an answer 2. So I'll just add 2 because I'm adding two of these, occurrences straightforward. And then I'll add 2 plus AR of 3. Why I'm adding 2 is because I'm taking the two elements, I'm making pairs of elements because I have to keep it even. So I am taking the pairs of elements and thus the 2 and the answer for the third one and the answer for the index minus 1, whichever is the maximum. Either deleting this, if I delete this and I take up till 3, then answer will be ARR of 2. Otherwise answer will be 4. The maximum one I am taking, I am making a maximum even string which is even, and then I'll subtract it from the whole, and then I'll subtract its length from the length of the original string, which will give me the minimum number of elements that has to be deleted. That is what I have done here. Okay, so I took an answer an ARR. I did it with one based indexing, so to avoid that clashes when it is zero. No. So for last occurrence, I took an array of last occurrence because there are 26 alphabets. So I took the last occurrence of 26, where I will store the last occurrence of each of the characters. So I just, you know, if the last occurrence is not equal to zero, I added two, and to the answer of index minus one, then I took the maximum, and then I updated the last occurrence, and I just printed the length of the original array minus the length of the even array which I made. Moving on to the next question. GCD and LCM. Okay, so you are given an integer n. You have to find four positive integers such that a plus b plus c plus d is equal to n, and GCD of ab is equal to LCM of cd. Okay, so so then n will be greater than 4 and less than 10 to the power 9. Okay, so basically what I did was I chose that the LCM of 1 and 1 will always be 1, and the LCM of any other integer with 1, and the GCD of any other integer will always be 1. Let me just give an example. So the GCD of, it doesn't matter, x comma 1 will always be 1, because 1 is the only one that will divide both of them, and the LCM of 1 and 1 will always be 1. So I took the given integer, I subtracted 3 from it, and then I just displayed it. Let me show you my code. Yeah, I just subtracted 3 from that and then displayed 3 times 1. So the GCD of n minus 3 and 1 will be 1, and the LCM of 1 and 1 will be 1. Okay, so moving on to the next one. Yeah, array cloning we have done. Next one. Yeah, bracket sequence deletion. Okay. You are given a bracket sequence consisting of n characters, closing bracket and or opening bracket. You perform several operations with it. During one operation, you choose the shortest prefix of the string that is good and remove it from the string. Okay. So good prefix is considered good if one of the following two conditions is satisfied. This prefix is a regular bracket sequence, and this prefix is a palindrome of length of at least 2. Okay, so regular bracket sequence, basically regular bracket sequence, the number of openings and the number of closings are equal, and they are respective of each other. So here, let's take an example of this one. The first one is closing, opening. Then the inner one is closed with the closing bracket. Then the outer one is closed with the closing bracket. Then again an opening bracket, and then again a closing bracket. So the count will be equal to 0. So this is called a regular bracket sequence. Okay, and an irregular will be like the number of opening and closing will be different, and the position of opening and closing will be different. Palindrome, we know what is a palindrome: 1 to 1, left side same, right side same. So You have to stop performing when there is a it's not possible to find a good prefix. Okay. So the first input test cases will be 10 to the power 4, and test case contains an integer 5 and 10 to the power 5, and it is guaranteed the sum of n over all the cases does not exceed 5 and 10 to the power 5. That means we can traverse through the array. Okay. So what I did here was basically, let's have a string like an opening, a closing, a closing. Let me just copy an example, then closing, and then closing. So if we look at this, the starting one, if anything that is, if any bracket that is similar to the starting bracket, if it comes anywhere like this one, then it will be a palindrome because the left and the right will be, mirroring itself, and then we can delete the shortest one. So either we have to see for a regular bracket or we have to see for a palindrome. Whichever comes first, we'll just subtract. So for a regular bracket, we know how to do it. Like let me just show you. Like let's just take an example for this. So we'll maintain a stack. We'll have each character once the opening bracket, and when the top of the stack will be an opening bracket and the next character we have a closing one, we'll pop out this one. So for this, let me just trace the stack. This one first, an opening bracket will go, then again the opening bracket will go, then we encounter closing bracket, so the opening bracket will be popped out, then again a closing bracket, opening bracket popped out, stack empty, again an opening bracket goes in, the next bracket encountered is a closing bracket, stack we pop out, and the stack is empty. Thus a empty, thus a regular bracket sequence. Okay, so the same I did. I found out the regular bracket sequence and a palindrome, whichever occurred first. I just kept, the instance of my last index. Let me just show you. So I took a string, the bracket string. I took it as an input. Then I declared a stack of characters. Pushed the first element of the string of brackets and initialize last index with -1 and the number of operations with 0. Okay. The starting index will always be the start of the array or the start of the array of characters. So what I did was traverse through the whole array, and if I found a palindrome, I incremented the operations by 1, and then I just emptied the whole stack. Then I arbitrarily assigned any character value to the starting index, starting character, and again in the if box, if the stack is empty, then I push the first value that is encountered and initialize the starting character as the top value, and then continue. And if the stack, this is the one that tells me the regular bracket sequence, that is the top is not equal to the character that is now being iterated, and if the character now being iterated is a closing bracket, if it is a closing bracket, then we'll just pop it out. It is similar to this one. Like if we have the top has this one, and the iterating the character being iterating is this one, so it will represent a regular bracket sequence, and we'll just pop out the top one. And then if the character, if the array is empty, so what we'll do is we'll initialize the last index, and the starting we'll initialize the starting, and then we'll just increment operations by one and display the operations, and the last and the remaining characters will be the size, because we are taking, because the size is n minus last index minus 1, because it is a zero based indexing, so n minus 1 minus last. Let's move to the question. So a theater square in the capital city of Poland has rectangular shape with the size n into m meters. On the occasion of the city's anniversary, a decision was taken to pave the square with the square granite flagstones. Okay, each flagstones of size a into a. What is the least number of flagstones needed to pave? It is allowed to cover, the theater, but should not. The square has to be covered as a whole. The sides of the flagstone should be parallel to the sides of the square. Okay, so if we ignore this one, that the size of the flagstone should be parallel to the sides of the square. So if we are having a box like this, then uh, what we can do is we can take a square array. We can put it like this also. Put it in any shape like a rhombus or a kite or any such shape. Okay, so it doesn't matter. But now that it has specified that the corner should be aligned, so we are left only with this sort of representation. Here the corners are parallel with the square. So when we see the input size, it can be 10 to the power 9. So what we have to do is we have to individually find the number of squares needed here, the number of squares needed here, and then we'll just multiply it both to find out, you know, the total number of squares, as it can be greater than. So we have to find the least number of squares needed to cover this whole group. So just divide m by a, take a C loop and multiply it, m by a, take a C. The catch of this question is that you cannot use the seal function, as when it will be 10 to the power 18 or something, it will show in a format of 1e18 or something. So what you can do is you can use the simplest form is m minus 1 plus a divided by a to find the seal of m by a. Let me just show you my notes. It gets easy, but this is the trick part. So what I did was m plus 1, m plus a minus 1 divided by a, then multiplied both, as it is parallel. So we have to take out for x-axis how much we need for y-axis, and then we just multiplied it with the whole. Moving on to the next one. Okay, so this is string task. What you have to do is Peter started to attend programming lessons. One of the first lesson, his task was to write a simple program. The program was supposed to do the following: in the given string, consisting if upper and lowercase Latin letters. It deletes all the vowels, inserts a character, a dot between before each consonant, and replaces all uppercase with corresponding lowercase. Okay, so the vowels are A, E, I, O, U, and Y, and rest are consonants. So 100 lines. Okay, so we can do this. It's an easy question. What we have to do was like we have a string A, A, B, X, Y, Z. First, we can remove the first we can turn everything into a lowercase by adding 32 uh, to the ASCII value of the capital is the capital A to Z is I think from 95, no, sorry, from 65 to 90, and the smaller ones A to Z 97 to 122. Yeah. So if we'll add 32, we'll get the smaller ones. So first we can convert them to smaller, then take out those all those initialize a string, an empty string, and then take out all those vowels, and then just print it with a dot. Let me just show you that code. What I did was I declared a check vowel function that returns true if it is a vowel and returns false if it is not. And then I just input the string, declared an empty string, iterated through the original strings, length, and then first of all converted those characters. Then I concatenated, the consonants with the empty string. And what I did was I just printed it, the character with a dot, preceding with a dot. So that's all for today. Let me get back to you tomorrow. Thank you.